Hello friends, welcome to engineering tutorial. In today's video we are going to start a new series of discussions which will be about electrical machines. So the first topic will be a basic introduction part where we'll discuss some basic introductory concepts related to electrical machines. Okay, so the first thing is what is an electrical machine. Okay, so an electrical machine is a device which is designed basing upon the principles of electromechanical energy conversion. Okay, most of the electrical machines that we use, that come across in our day-to-day lives, they are based on electromechanical energy conversion. So what is this electromechanical energy conversion? It means the electrical energy is converted into mechanical energy, or the mechanical energy is converted into electrical energy. So it is based on the principle of conservation of energy. It means that energy can neither be created nor be destroyed. It can only be converted from one form to another. So here the electromechanical energy conversion principle, according to it, the electrical energy is converted into mechanical, or the mechanical energy is converted into electrical. Okay, so in order to elaborate, as I said, it is based, the electromechanical energy conversion obeys the principle of conservation of energy, which means that the interchange of energy between the electrical and mechanical system involves no loss of energy. The electrical energy is converted into mechanical, or the mechanical is converted into electrical. So this energy conversion, okay, between electrical and mechanical, it involves certain basic elements, okay, certain basic components. The basic components of the electromechanical energy conversion system is the electrical system, the mechanical system, and the coupling system called as the coupling field. Okay, so the electrical and mechanical system, they lie on the two extreme points depending upon the mode of energy conversion, whether the input is electrical or mechanical, or the output is electrical and mechanical. Depending on that, they lie on the two extreme points. The coupling field combines, okay, holds or connects both of them together, the electrical and the mechanical. Whether the electrical lies on the input or the mechanical lies on the input, the coupling field lies in between the electrical and the mechanical systems. Now when I say electromechanical system, only two things come to our mind: the electromechanical conversion system. Okay, and most of our discussion will heavily revolve around these two basic electrical machines, and those two machines are motor and generator. So a motor is an electrical machine which converts electrical energy into mechanical energy. Okay, that is a motor. And a generator converts mechanical energy into electrical energy. Okay, so we'll discuss about motor and generator in detail. There will be a lot of videos related to that, but here we are just going through the basic introductory concepts. So in order to understand what a motor is and what a generator, the motor converts electrical energy into mechanical energy, and the generator converts mechanical energy into electrical energy. And most of the discussion about electrical machines will revolve around these two concepts. There will be other things as well, other instruments and machines which also obey the electromechanical energy conversion system, but most of the discussion will be around motor and generator, more than 70%. Okay, so the electrical generator, as I said, it converts mechanical energy into electrical energy. So mechanical energy means some movement, some rotation, there will be some rotating components which will be converted into electrical form, that is voltage or current. So in that case, the mechanical system lies on the left at the input side, and the electrical system it lies at the right, the output side, and the coupling field is in between. Whereas in the electrical motor case, the electrical system is on the left at the input side and the mechanical system is at the right, the output side. It converts electrical energy into mechanical energy, that is voltage or current is converted into some kind of rotatory or mechanical movement. Now, the coupling field, okay, the coupling field can be of two types, okay. It can either be a electric field or it can be a magnetic field. There are two choices that we have, whether the coupling field is of electric nature or the coupling field is of magnetic nature. So first, the electric field as a coupling medium. Now what is the basic principle that is involved in it? So if let us we consider two oppositely charged plates of a capacitor separated by a dielectric medium, okay, two oppositely charged plates, one plate is negatively charged and one plate is positively charged, okay. So it is a simple parallel plate capacitor. So we know that as per Coulomb's law, a force of attraction will exist between these two oppositely charged plates, okay. As per Coulomb's law, when two objects which are of opposite charge, which have opposite charge in them, they are placed close to each other or with some distance between them, there will be naturally a force of attraction between them, okay. Like charges attract each other, like charges repel each other, opposite charges attract each other, okay. So as these are oppositely charged, they will attract each other, there will be a force of attraction. This is governed as per Coulomb's law. So okay, let us discuss Coulomb's law a bit. So the Coulomb's law gives us a mathematical representation about the magnitude of the electrostatic force of attraction or repulsion between two charges, okay. So as per Coulomb's law, the magnitude of force between two charges q1 and q2 is given as per this mathematical expression, which is the proportionality constant k subscript c with q1 q2 by r square. It means the force is directly proportional to the product of the two charges, the magnitude of the two charges, and is inversely proportional to the square of the distance between them, okay. So let's suppose there are two charges with magnitude q1 and q2 coulombs separated by a distance r. The force between them is given by kc into q1 q2 by r square, directly proportional to the product of the two charge magnitudes and inversely proportional to the square of the distance. So this is the Coulomb's law. So in electrical field, when electrical field is chosen as the coupling medium, the force of attraction governs Coulomb's law. Now, as there are two plates which are oppositely charged and are separated by a certain distance, there will be a force of attraction between them. So this force of attraction, if one of the plates is held constant, okay, stationary, and one is mobile, one is free to move, then because of the force of attraction between the two plates, the movable plate will move to and fro. It means we are converting electrical charge into mechanical motion, or electrical energy into mechanical energy. Okay, so in a way we are converting electrical energy into mechanical energy when we keep one of the plates fixed and the other one movable. So by Coulomb's law, the movable plate will be free to move either towards the plate or away from the plate. So by this we are converting electrical energy into mechanical energy. Okay, so here there are opposite charges, so the plate will move towards the the positive charge plate. Suppose both the charges would have been same, in that case the plate would move away, because like charges repel, opposite charges attract. So this is the first, electrical into mechanical. Now mechanical to electrical. So the mechanical to electrical can be understood by the principle of parallel plate capacitor. Okay, so the capacitance of a parallel plate capacitor is given by epsilon A by D, where epsilon is the permittivity, A is the overlapping area between the two plates, and D is the distance between the two plates. Okay, so in the second case, to convert mechanical to electrical energy, if we apply an external force on one of these plates, okay, if we apply an external force on one of these plates and try to increase or decrease the separation between the plates, okay, if we try to increase or decrease the separation between the two plates, there will be a change in the capacitance. Now you see, the capacitance is directly proportional to the permittivity of the medium and the overlapping area, and inversely proportional to the distance between the two plates. So if we increase the distance between the two plates, there will be a decrease in capacitance. An increase in distance causes a decrease in capacitance, okay, and a decrease in the distance will cause an increase in the capacitance. So by mechanical movement of one of the plates, okay, by mechanical movement of one of the plates, the electrical capacitance associated with the the parallel plate capacitor will change. Okay, so mechanical movement causes a change in the electrical characteristics of the parallel plate capacitor. Okay, the movement is of mechanical nature and the capacitance is electrical quantity. So here mechanical movement causes a change in the electrical characteristics. So we are converting mechanical energy into electrical energy. So we have used both the principles. Okay, in first case, one of the plate is allowed freely to move under the influence of the force of attraction or repulsion. As a result of that, we converted electrical energy into mechanical energy. And in the second case, we applied external force and increased or decreased the separation between the two plates. As a result of that, the capacitance changes and we converted mechanical into electrical energy. Okay, so we performed both conversion, electrical into mechanical and mechanical into electrical. Okay, so the electrical into mechanical conversion obeyed Coulomb's law. Okay, and mechanical into electrical simply followed the basic parallel plate capacitor principle, where a change in the separation between the two plates causes a change in the capacitance, which means mechanical movement causes change in the electrical capacitance. Now this is all about electrical field as the coupling medium. Next is the magnetic field as the coupling medium. So in order to understand the use of magnetic field as a coupling medium, we have to understand Fleming's rule. Okay, so we know, as per Fleming's rule, a current carrying conductor, okay, when it is placed in a magnetic field, it experiences a force and tends to move. Okay, so it generally involves electrical energy, converting electrical energy to mechanical energy. Okay, now if we apply an external force on that conductor, and when it is kept in a magnetic field and we move the conductor in a magnetic field in a certain direction, a current will flow through that conductor. So here the mechanical movement or the mechanical energy is converted into current, which is an electrical characteristic. So this is mechanical energy into electrical energy conversion. So this involves both Fleming's left hand and right hand rule. Okay, so the behavior of current carrying conductors placed in a magnetic field is governed by Fleming's left hand rule and right hand rule. So this Fleming's rule, if we just understand a few basics, as per Fleming's left hand rule, it gives us the behavior of the direction of the flow of current through the conductor, the direction of the magnetic field, and the direction of force. And both these three parameters are generally in mutually perpendicular directions. That is, the flow of current, the flow of the direction of the magnetic field or the flux, and the direction of force or motion are in three mutually perpendicular directions. And same is the case for Fleming's right hand rule. Okay, so the first case, that is when a conductor is placed in a magnetic field, a current carrying conductor is placed in a magnetic field, the direction of the force is given by Fleming's left hand rule. This first case is Fleming's left hand rule, and the second case, that is applying an external force on a conductor placed in a magnetic field causes a current flow through it, it is given by Fleming's right hand rule. Okay, so we have to understand these two things very clearly. That is, when a current carrying conductor is placed in a magnetic field, it experiences a force and tends to move. In this case, there is electrical energy into mechanical energy conversion, and when we move a conductor in a magnetic field, a current flow is caused in the conductor, which is mechanical energy into electrical energy conversion. This is electrical energy into mechanical energy conversion, this first case, and the second case is mechanical energy into electrical energy conversion. And both of these are governed by Fleming's left hand and right hand rule respectively, and the direction of the force, the direction of the magnetic field, and the direction of flow of current are in three mutually perpendicular directions. So these are some of the basic concepts related to the magnetic field as a coupling field. So this is basically the whole arrangement that we can perform to understand the behavior of a current carrying conductor in a magnetic field. That is, we have placed a conductor carrying current with the help of this DC voltage source, and have placed it in the magnetic field of a, let's say, a horseshoe magnet. So as a result, it will experience a force and it will tend to move as per Fleming's left hand rule. And if we cut off this deactivate this voltage source and simply move this conductor in this magnetic field, a current will flow through it as per Fleming's right hand rule. So in both the cases, there will either be a electrical to mechanical energy conversion or mechanical to electrical energy conversion. So if I say, out of the two coupling fields, electric field and magnetic field, which one is used? It is the magnetic field. Okay, the electric field is never used. Only in some rare cases the electrical field is used in electromechanical devices, but mostly it is the magnetic field which is used as the coupling medium in electromechanical devices, obeying the Fleming's rule. Okay, so the magnetic field, so whenever we will discuss electromechanical devices, it will always be the magnetic field as the coupling medium. Okay, so these are some of the basic introductory concepts that we have discussed about the electromechanical devices or the electrical machines. So we started from the basic definition of the electrical machine, the principle of electromechanical energy conversion, the components of the electromechanical system, then the electrical field as the coupling medium, and then the magnetic field as the coupling medium. And we discussed the uh, principles that were used in the electrical and magnetic field. So in case of electrical field, the two principles that are followed are the Coulomb's law and the principle of parallel plate capacitance. In case of magnetic field, it is the Fleming's left hand and right hand rule that comes into play. So in the next video, we'll discuss some more concepts related to electrical machines or electromechanical machines involving magnetic field as the coupling medium. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.